Okay, so today we are going to do 3.7, and like I said, it's pretty short and sweet. It's going to be on graphing linear inequalities. Okay, it's very similar to graphing linear equations, which are lines. Okay, we're going to use the same method that we graph in MathLab, right? We're going to get 2 points, plot those 2 points. MathLab will automatically connect them. But before we get into there are a couple of differences when you're graphing inequalities instead of equations. Okay, inequalities have the greater than. So when you're graphing inequalities instead of equations, instead of an equal sign, you're going to have a less than or greater than sign. So one that'll look like that, or sometimes they look like these. Okay, so this is less than and greater than. This is less than or equal to. That's what that bar underneath, that's like half an equal sign, or greater than or equal to. Okay, that tells us what kind of line are connecting our points. If you do not have the equal to bar, your points are connected with a dashed line. If you do have an equal to bar, your points are connected with a solid line. So let's look at one like number 1. You have y is greater than x minus 4. So just like when I'm graphing lines, I can go ahead and put this in y equals. Okay, I can just put it in my regular y equals. I think this is the easiest way. So let's just go to y equals, clear out whatever's in there, and put in x minus 4. So you'll just put in x minus 4. Let's go ahead and graph it. This is going to be a straight line. Okay. Now, I am curious. I need to know, in order to put this in MathLab, 2 points on this line. So remember how to get to the points. You would just hit second and then hit the graph button again, and it'll give you a table with as many points as you need. Okay, I just need 2 of them. Just pick any 2 you want. You do 0, -4, and 1, -3. So 0, -4 would mean left and right 0, down 4. So nowhere left or right, down 4. 1, -3. So that's to the right 1 and down 3. Now, MathLab's default setting is as soon as you put that second point, it's going to connect it with a solid line. Okay, now just like it always does. Now remember, over here in your toolbox, you've got all the different shapes that we've been graphing. Okay, this one again, just like when you're graphing a line, you'll tell it a line, plot the points, but it's going to automatically connect it with a solid line. Underneath these shapes, actually, I think it's not. It'll have a dashed symbol, which again, this will automatically connect solid. You'll just click on this. That's what'll turn it from the solid line into the dashed line. Okay, so you'll want it to be dashed this time, right? Since it doesn't have the equal to bar. Now, it wants to know, where are the y values greater than this dashed line? Okay, if you're greater than and you're y, that means you are above. So greater than that line. Also down here in your toolbox is a paint can. If you hover over that paint can, it's going to call it your shading tool. So you'll click on this to tell MathLab that you're about to shade. So click on the paint can, and then you can click, since it's greater than, anywhere above the line. It'll shade that whole region for you. You can click, just click your mouse on anywhere. As long as you are above this line, it'll shade that whole region for you. All right, number 2. 5x minus 3y is less than or equal to negative 9. Okay, so in order to put it into y equals, I have to get the y by itself first, right? So I need to isolate the y. So I'm going to do that by subtracting the 5x first from both sides. That'll cancel the 5x. I have the negative 3y left is less than or equal to. Now remember, those 2 terms on the right side, they're not like terms. You can't put them together, right? One's an x and one's a constant. So you just bring them both down, and it doesn't matter who goes in front. I just always put my x term in front of my constant because I like that way it looks like that. So I'll have negative 5x, then the minus 9. Now I got to divide everybody by negative 3 to cancel out that negative 3. So now y, here's another thing about inequalities. Anytime you divide both sides by a negative number, this symbol flips around. So it goes from less than or equal to greater than or equal to. And that's when you divide by a negative or multiply by it. Negative over negative makes that positive 5/3 x. Negative over negative makes that positive 3. So this is what will go in your y equals to get your points. So you have 5 over 3x plus 3 in your y equals. And again, I always like to hit graph just to see what it's going to look like. And then hit second graph again. And just avoid all those points where your y is some crazy decimals. So let's see, 0, 3. And I'll do 3, 8. All right, 0, 3. So left or right, 0, up 3. And then the next one is at 3, 8. So to the right, 3 and up 8. Now remember, MathLab, as soon as you put that second point, is going to connect it with a solid line. And this one does need to be solid, right? Since it has the equal to bar. So I just leave it alone. I don't change it to dashed. Then click your paint can because you're about to shade. Y is greater than, which means click above the line. All right, number 3. This one just says x is greater than 4. Okay, so I'm not putting that in y equals because there is not a y in the equation or the inequality. So let's think about where x equals 4. If your x coordinate is 4, what does that mean about your point? If your x is 4, every single point, your x is going to need to be 4. Doesn't matter what the other one is. Okay, it doesn't matter what the y is, the x has to be 4 to make this line. Well, if your x is 4, if I do this one, 4, 0. So to the right 4, up and down 0. This one's at 4, -3. Again, I'm going to the right 4. This time I'm just going down 3. So if I did another one, again, the only thing that has to happen is the x has to be 4. This one would say to the right 4, up 1. So what kind of line is this making? The kind that goes straight up and down. It's just going to make a vertical line. Again, it'll connect it solid. Since this one doesn't have the equal to bar, you're going to have to click the dashed thing. Now, up until this one, we've been shading above or below the line. I can't do that with a vertical line. But what is this statement saying? Where are the x's greater than 4? What is, if I'm just looking at it, what is this one's x? 5. Is that greater than 4? Yeah, which means that whole side. What is this one's x? 3, which is not greater than 4. None of the x's over here are going to be greater than 4, but all the x's to the right of that will be greater than 4. So you'll click your paint bucket and shade to the right of that for your x values to be greater than 4. Okay, I'm going to put number 4 just right up here next to it just to compare them. This one says y is less than or equal to -1. So this one doesn't have any x values, or in other words, it doesn't care what x is. But every single point that you put on the graph, the y needs to be -1. So again, doesn't matter what x is, y has to be -1. Doesn't matter what x is, y has to be -1. So you can make your x be anything you want, as long as your y is -1. So let's see, this one, 0, -1 means left and right 0, but down 1. This one, +3, -1, which means to go to the right 3 and again down 1. If your y is -1, it doesn't matter how far left or right you go, but you have to go down 1. So that is going to make kind of the opposite of vertical, horizontal line. And this one is solid. And now I can shade above or below a horizontal line. What does this say? Where are the y values less than this line? What does less than mean? Below. So just get out your shading tool and shade below. All right. Last one. This one's going to have 2 inequalities that it wants you to graph on the same grid. And the answer, and it's going to be a multiple choice, is where the shading of the two inequalities overlaps. All right, my two inequalities are y is greater than or equal to x plus 3. Y is less than or equal to 2 minus x, 5. So I'm going to put them both on the same XY graph. So I'm going to put this in y equals and get 2 points. So y equals x plus 3. And then hit second graph. Pick 2 points. So I'm going to do 0, 3, and 1, 4. And plot those. So 0, 3 is left to right 0, up 3. 1, 4 to the right 1, up 4. They both have equal to bars. So when I graph both of the lines, they're both going to be solid. Now I am going to go ahead and shade where this needs to be shaded. This is y is greater than this line. So above it. Now I'm going to do the same thing with this one. So go back to y equals 2 minus x this time. And you could have put that in the y2 and just kept them both up there. Second table to get your 2 points. 0, 2, 1, 1. Again, I'm just grabbing random points out of that. So 0, 2, I'm going to do it a different color. So, because remember, the answer is where the shadings overlap. So 0, 2, left and right 0, up 2. And 1, 1. So to the right 1 and up 1. Again, it's a solid line because it has the equal to bar. This one wants to know where are the y less than that red line. So where am I shading on that red line? Below it. So again, the answer is multiple choice. So all 4, A, B, C, and D are both going to have those lines. One of the answers is going to have that shaded, one will have that, one will have that, and one will have that. Which one is shaded by both colors? This one right here. So that's your answer, is the one that shows the shading right here, because that shows where the y values are greater than the green line and less than the red line. Okay.